Hello students, welcome back to maths class. We are doing homogenizing problems from exercise 4C. So same procedure for homogenizing problems. So we will homogenize the curve by using the line so that we will get one combined equation of OA and OB. That is called homogenization. Okay, so here now read this question. Second question we are doing by homogenization from the exercise 4C, right? So important for 7 marks. So find the value of k if the lines joining the origin to the points of intersection of the curve and the line are mutually perpendicular. So whenever homogeneous problem is there, we will take this diagram. So this is the given curve, right? This is the given line. Okay, so this is nothing but it is given that find the value of k if the lines joining the origin, these are the two lines, OA and OB are the two lines joining the origin and point of intersection of the curves, right? So those two are mutually perpendicular. If those two are mutually perpendicular, then find the value of k. This is your question. Previously show that in previous problem, previous class, right, we solved one homogeneous problem. There we have to show that OA is perpendicular to OB, right? Show that those lines joining the origin and the curve, right, are mutually perpendicular. That is the previous question. Now your question is, if already the lines are mutually perpendicular, find the value of k. Okay, so first thing is homogenization is as usual. So what is the given curve equation is? So curve equation is, what is your given curve equation? It is 2x square minus 2xy plus 3y square plus 2x minus y minus 1 is equal to 0. You consider that as one equation. Okay, and the line equation is, what is your line equation? X plus 2y is equal to k. What I said in homogenization method, right side of the line must be equals to 1. We have to make it as 1. So divide both sides with the k. Okay, then what happens to your line equation? X plus 2y by k is equal to 1. You consider this as your second equation. Now homogenizing. Okay, so equation 1 with equation 2, with 2 we are homogenizing. What is the procedure I said? First x square term, right, 2x square is there, minus 2xy plus 3y square will be as it is. Next x term into 1, right, next y term into 1, next constant term into 1 square. Okay, constant term into 1 square we have to take. So wherever 1 is there, in that place we got here 1 is equal to x plus 2y by k. So we have to take. So 2x square minus 2xy plus 3y square plus 2x into 1, in one place we have to write x plus 2y by k. Next minus y into 1, x plus 2y by k minus 1 into 1 square, right. So it is x plus 2y by k whole square is equal to 0. Okay, so observe carefully. So we can write 2x square minus 2xy plus 3y square plus, 2x square plus 4, 2 to the 4xy by k, okay, minus We can write, yes, minus yx, right, minus 2y square by k minus of, this is your a plus b whole square form, a square plus b square. Otherwise we can keep this minus outside, right, and we will keep the bracket. So here also we will keep, so that you don't get a confusion after the taking LCM, right. So x square plus 4y square plus a plus b whole square, a square plus b square plus 2ab, so 4xy, okay, by k square is equal to 0, okay. So here minus is taken outside only, just I multiplied y into x and y into 2y, okay. So we can write like this. So now what will be your LCM? LCM is k square, okay. So LCM is k square. So if we take the LCM as k square, here we don't have k square, so we have to multiply all these values with k square. So 2k square x square, next minus 2k square xy, next plus 3k square y square. Here only k is there, for these two k is there, but we have taken k square, so we have to multiply these two terms with k, these two terms with k. So come on, we can write that as 2k x square, okay, plus 4k xy. Similarly, next term also with the k, downwards only k is there, but I have taken LCM as k square, here highest is k square, that's why. So come on, open the brackets, minus k xy yx, both are same, next minus 2k y square, okay. This one as it is already k square is there, so the values as it is we have to take, just open the brackets, minus x square minus 4y square, okay, minus 4xy is equal to 0, okay. So is equal to, write x square terms together, xy terms together and y square terms together. X square terms together 2k square x square, next 2k x square, here is there and here also it is there, minus x square, okay. Next xy terms we will take, so minus 2k square xy, okay, 4k xy minus k xy, 3k xy, 3k xy, okay. So any other xy term over here also it is there, minus 4xy, okay. Now you take y square terms, 3k square y square, next minus 2k y square, next minus 4y square is equal to 0. Send this k square that side, right. If we send anything, it is dividing, if you send other side it will multiply, 0 into anything 0 only. Now from this you take x square common, then it is 2k square plus 2k minus 1 into x square. Next xy term minus 2k square plus 3k minus 4 into xy term. Next y square term 3k square minus 2k minus 4 into y square is equal to 0. Which form it is? It is of the form, come on, ax square plus 2hxy plus by square is equal to 0. So since OA and OB are mutually perpendicular. Here it is given that since OA is perpendicular to OB, coefficient of x square plus coefficient of y square is equal to 0. Since they are perpendicular, they have to satisfy this one. So, coefficient of x square plus coefficient of y square is equal to 0. What is the coefficient of x square? Coefficient means its multiple, right? X square multiple is called x square coefficient. Y square multiple is called y square coefficient. So, it is 2k square plus 2k minus 1 plus 3k square minus 2k minus 4 is equal to 0. So, plus 2k minus 2k cancel. So, 2k square plus 3k square 5k square, right? Minus 1 minus 4 minus 5 is equal to 0. So, it is 5k square is equal to 5, k square is equal to 1, k is equal to plus or minus root 1, that is plus or minus 1 is the answer of your question. Okay, so come on, what is this? Whenever curve, general second degree curve equation is given and line is given, and it is given that lines joining the origin to the points of intersection of the curve means it is homogeneous problem. Okay, so here it is given that those two lines are mutually perpendicular, right? So, OA and OB are mutually perpendicular. Then find the value of k. That is the question for you. So, first you take the curve equation and the line curve equation as it is, equation number 1. Next, from the line equation, try to get right side 1. How we will get? So, first send the constant. Here it is constant is right side only. So, try to make that right side value equals to 1. So, divide both sides with k, that is your 1. Okay. Then homogenizing 1 with 2. X term into 1, y term into 1, constant term into 1 square. Wherever 1 is there, you substitute, right? And simplify carefully. This is a plus b whole square form. That's why downwards k square, upwards a plus b whole square. So, your LCM will be k square. After that, you write all x square terms together, xy terms together, y square terms together and take outside, then your equation will be in ax square plus 2hxy plus by square, nothing but the combined equation of OA and OB. Whenever combined equation of OA and OB is given and OA is perpendicular to OB, then coefficient of x square plus coefficient of y square is equal to 0. So, coefficient means its multiple, x square multiple plus y square multiple is equal to 0. Then we got 2k minus 2k cancel, 5k square minus 5 is equal to 0, 5k square is equal to 5. So, k is equal to plus or minus root 1 value is 1. Okay. Question is find the value of k. Okay. So, we got k value. Practice this problem perfectly, most repeated. If you see in your material or any model paper, so many times repeated question. Compulsory one homogeneous problem will be there in final paper, okay, from pair of straight lines. Okay. So, practice this perfectly from the beginning to ending, and you have to draw the diagram also. We are doing B problems, geometry problems, right? So, we have to give the support with diagram. Whenever I have given any diagram, you have to draw it. Okay. So, that's all for today. Have a nice day.